We're going to jump right into the presentation now, and we're going to be covering the 6 biggest concerns of using 3D printed parts. So we've been helping the NHS recently producing face shields, which is something that any of you guys can jump in and start doing yourselves if you have an FDM 3D printer. We've also been producing nasal swabs to help battle the spread of COVID and help the testing effort to make sure that people are we're aware of who is infected with COVID in certain areas. And we're also 3D printing little bits and pieces to help stop the spread of coronavirus. So to your left is myself. I'm George, so I'm an industrial 3D printing consultant, and I'm joined by my colleague Tom, who's a technical engineer and is going to be answering perhaps some of the more difficult questions you guys might be putting our way towards the end of the webinar, which he looks very happy about. So the 6 common questions that we're going to address in today's webinar are, firstly, how and where does 3D printing add monetary value to the business? It's a real big one, which we're going to spend a good amount of time going through. And then secondly, what is the required investment and when will you guys see a return? And what are our processes for going through that? And will the 3D printed parts be strong and accurate enough? Followed by what is the best 3D printer and materials for your business, depending on what applications you're going to be tackling, and what sort of training and ongoing costs are going to be associated with a 3D printer. And lastly, tell you a little bit more about solid print and the information that we give out and where it comes from. So firstly, we're going to be going through Markforged. Markforged is one of our 3D printers. It's an industrial level 3D printer, and we're going to talk through how Markforged 3D printers can add monetary value to a business. So Markforged composite technology is a patented technology, and the best way to describe it is by using a concrete structure as a reference. So with a concrete structure, you will have a lot of rebar going through the structure, which will drastically add strength to the structure. So instead of rebar, Markforged 3D printers use a continuous fiber strand, and instead of that concrete surrounding that rebar, a Markforged printer will be using a plastic which is nylon based, which we'll discuss a little bit further on the next slide. So to illustrate this process, you'll start off with a CAD model and you'll export that into the software that comes with the Markforged printer, and you'll actually select the areas where you want to be putting the fiber reinforcement into the parts. And you can select that very finely. So if you've got a small detail on a part, you want to make sure that that detail is a lot stronger than, say, the rest of the part. You can select those areas and strategically place fiber reinforcement where you need it. So once you've selected where you want to be fiber reinforcing a part, you will then send the part to the printer, and it will swap between 2 different materials, the fiber reinforcement material and the base plastic material, and it will basically print the part with the fiber embedded inside the plastic, so it's not actually visible once the part is finished printing. The base plastic is something called onyx, which we'll talk about in a little bit more detail later on. Onyx is twice as strong as ABS alone, and when a part is fiber reinforced, the strength then exceeds aluminium. So where does Markforged 3D printing commonly add monetary value to a business? One case study that we'd like to talk about is press brake punch. So this one was made by Centerline Solutions. So with this press brake, it's actually bending a piece of sheet steel. So this press tool has been carbon fiber reinforced, but then it's also making use of another feature on the Markforged printers where you can pause a print and drop steel components into a print to reinforce the part even further. So that's how this press tool is able to bend bits of sheet steel. There's a short video that I'll show on the next slide. We'll actually show this press in action so you guys can fully wrap your head around what's going on there. And then the one in the middle is one which is made by Martac, and this is actually a seawater intake. And this shows, the chemical resistance of Markforged material as well. So this is actually an end-use part that's being embedded in seawater for a prolonged period of time. So the layer adhesion on the Markforged 3D printers is that good that no water can seep into parts. So we've actually done some testing with the RNLI, and they've proved that the Markforged parts are suitable to go on their lifeboats. And then to the right, we've got a Siemens application here for gas and power, where they have made a repair tool, which has saved them 35 weeks over the current sourcing method and $8,000. So just to touch on the savings made on each of these case studies, the Centerline Engineering Solutions press tool was previously being made over the course of, well, it was taking 10 days to get the press tool delivered and in use. And it's only taking just over 1 day to get that press tool 3D printed, allowing for a much higher project throughput. Also, the fabrication cost of the press tool is significantly less over the aluminium alternative. And in the center, the fabrication time, again, drastically reduced on the seawater intake, previously being CNC machined. And I mean, the CNC machining paths were very intricate, trying to get into that complex geometry, which was really driving the cost up. Whereas complex geometry doesn't cost you anything extra on a Markforged 3D printer. I just want to make sure that everybody in the webinar can hear us. So if you can hear us, if you could just raise your hand. Good, okay, everybody can hear us. It's good to know. So on to the next. So this is the press brake that I was talking about in the previous slide in action. So that's a sheet bit of steel there. And it's really not a thin piece either. It's almost 4 millimeters thick. And there's some cuts that have been put into that bit of sheet steel before it's being pressed. Then that press tool is able to actually bend that. So there may be bits of press tooling that you guys might have in house or other bits of tooling where previously aluminium or steel was the only option. Now we're starting to see 3D printing being used in all kinds of tooling. So here's another way in which Markforged 3D printers can add monetary value. To the left, we've got a mold which has been made in onyx material and then reinforced in a high strength, high temperature fiberglass. So that's being exposed to 150 degrees over a prolonged period of time. And that fiber reinforcement within that part is really helping to hold that part together and stop any thermal expansion. So again, massive savings on time here, 144 hours down to 60 hours, and the fabrication cost as well drastically reduced from $1,000 to $240 over the aluminium alternative. And then to the right, we've got a tool made by Eaton, which is used for pressing plastic tubes into hard plastic clips. So previously, this part was like kind of a jury rig thing to get out of welded, I can't remember what sort of metal it was, but then it was also machined out of polycarbonate. And what they were finding was that little dongle that's exposed at the top, called the strong locating feature in the picture, was actually shearing off when it was the polycarbonate alternative. And they found the Markforged part, they were getting far better performance than all the other iterations that they went through beforehand. Again, the fabrication time on that drastically reduced, and the cost as well drastically reduced. So again, more examples of tooling that can be made on the Markforged printer to make use of big savings. So Tom's going to take you through the Ultimaker section of the presentation.
That's great. Thank you very much, George. Good afternoon to everyone who's listening along. So yeah, we're going to have a quick flick through Ultimaker next. Again, just have a bit of a run through the actual printers themselves, who Ultimaker are, and again, those kind of benefits of what you'd be getting out of using the Ultimaker machinery. So, as I said, it's all about the how and where does Ultimaker 3D printing actually adding that monetary value in. There's a couple of nice little case studies here we're going to run through, as well as a little bit of information about the filaments and, as I said, Ultimaker themselves. So Ultimaker has been around since 2011. So the printers themselves have gone through several iterations since then, all kind of looking, and from kind of, I guess, the 6-foot test, about the same. But it's obviously the technology inside it has become more reliable. And what they've done is they've used, as it suggests at the bottom, the many supported filaments. So ones like copper 3D, filamentive, X-strand, they're all part of what's called Ultimaker's Materials Alliance. So they've already got profiles and information set up showing you exactly how to use the printers and how to use the materials from the get-go. So it's that kind of ability to kind of get up to grips and up to speed with the printers that's really making the Ultimakers a great option. And that's why it fits in really well with these examples we're going to run through here. So if you are needing to get kind of bureau work sent out or kind of quick plastic pieces for testing parts, then it's a really, really good option. So noise aware, the case study we're kind of looking on the left-hand side with the white components in that left image and the central image there. So they're functional prototypes created with an Ultimaker printer. And what it allowed noise aware to go through and do is actually to perform acoustic tests and transmission tests on site with customers, because they can quickly get the parts manufactured off their Ultimaker. Again, it's that cost analysis here we kind of go through and discuss a bit further. So when you're looking for the parts of the Ultimaker printer itself, it mentions it in dollars, but it's about $10 per product, and the time to print anywhere between 2 and 55 hours, depending on the size of it and the layer height. All these kind of things will be linking in together to give an overall quality and time for the overall print. And again, it's that comparison. That's what we're really looking at here. So when you're comparing it to the external vendor, they were looking at about $800 per part if it was a bureau service. And the time element, obviously, you've got to factor in their running times, their running costs, what they've already got in their queue, and obviously delivery service, especially at times at the moment delivery services are running a little bit slower. That is for certain. So having a printer actually in-house certainly helps to just eliminate those external factors that are outside of your control. The one on the right hand side just shows a very quick image. So for prototyping, for getting tests, getting an idea of sizes, so you can see all those joints there for that lovely looking chair. Print them out, get a feel for the components, now it's going to fit together, and you can get that done nice and quickly. So there's those little bit of information on the bottom right hand side. So what are the kind of things that Ultimakers really help with? Prototyping, any niche materials. I mentioned the Materials Alliance on that bottom left hand side. So for antimicrobial prints, you can use copper 3D. Filamentive, a great company and a really, really strong point for recycling. So all of their materials have come from recycled sources. And then if you're looking for a bit more strength, things like X-strand and BASF and Innerfill are a really good option. So design freedom, end-use parts, etc. All those kind of things I mentioned when we're going through that quick case study then. It's the ability to actually be able to go through and actually do any kind of customization. It's not going to really make too much of a difference overall print times, while allowing you to actually get the end result out. So another nice little case study here. It's one of Ultimaker's standardized ones. They did a few bits of testing with a company called Snow Business. So it's mainly for the film, TV industries. And what they wanted to have is, as you can see, that kind of that snow cannon itself. So again, it's that cost analysis and that looking for the reason why the Ultimaker printer is going to fit in very nicely for them. So what they really wanted to have was cost savings. They also want to have the ability to have it accessible and customizable. And furthermore, one of the other options they want to have a look into was actually using water-soluble PVA support material. So because of the Ultimakers having your 2 nozzles on them, on your left nozzle, they could run different materials. So I believe it was ASA for this one, because they wanted to have a bit of extra strength and that weatherproofing from the cold aspects. Then on the right nozzle, they're able to have PVA. So what you're able to do with PVA supports is you can print with it. It's going to ensure that you're not going to have any blemishes on the surface it's touching, because it's water soluble. You can then literally just run it under a tap, let it soak in a bath for a bit of time. It then won't completely dissolve away, but it will certainly turn a lot softer. When it turns softer, you can peel it off and you can get your part out of it. Printing with an S5 in the material station, which is one of Ultimaker's products in their range, certainly makes it a lot easier. A humidity controlled platform, ability to have your PVA sat in there for a length of time and just use whenever it's required. Again, just adds into the ability to not have to depend on anyone else. You know, you can kind of get these things printed to the quality that's required. Okay, so yeah, that's a little bit of a run through on how Ultimaker printers are going to work. So now what we'll do is we'll have a bit of a hop into Formlabs. So Formlabs is going to be a little bit of a different type of printer, as it's SLA, it's stereo lithography. This therefore means we're going to be using a resin. So this resin will be cured by a laser and basically creates injection mold style parts. And we'll have a bit of a run through as to why and how this can actually help out with yourselves. It's also worth mentioning that there is the SLS, your selective laser sintering, which is a powder-based 3D printer. That's going to be called their Fuse 1 product, and that'll be coming out later on in this year. So again, what we're trying to look through here is how and where does Formlabs 3D printing actually add monetary value. So we've got quite a few images here, and even hopefully on through this webcast, you're able to see actually the quality of the components. As I mentioned, it's that injection molded effect. That's the aesthetics you're really getting out of it. And you should also be seeing similar levels of performance as well. So they've got a whole host of materials. So if you're trying to replicate a nylon, they've got a specific material for that. If you're trying to create something that's going to be more like ABS, again, they'll have a specific resin for that. In that circumstance, that'll be their tough resin. So we've got all those different abilities to actually choose these resins and create, as I mentioned, those isotropic injection mold style parts. So your strength and your quality is going to look very similar. So in the center of the images, you can kind of see a mix of different colors inside there. So those purple ones are referring to their castable wax. So it's got a low burnout, 20% wax inside the resin itself, which allows you to therefore print the high quality, the detail itself in the printer, and then you can go and get it casted into metal, whatever it needs to be afterwards. The more orangey kind of looking colors, that's their dental resins, so you can have your BioSafe. So they've even got a specific printer to run through that directly. So if you were working in those kind of industries, they've got a printer there covered specifically to do that. It's like their normal run-of-the-mill Form 3, but just slight tweaks to make it as FDA approved as possible. Effectively, that was their goal with that individual printer. On the right-hand side, you can see there's a slightly different color going on there, and that's actually using what's called their high temperature resin. So if you're looking for about kind of 200-ish degrees, you can get that out of the resin itself. So we can use that for different types of casting processes. I'm going to work back against that first top left-hand side image, and what that is a plastic extrusion. So this is a nice case study we've seen with quite a few customers coming to us. They'll say, right, Solid Print 3D, need a bit of assistance. When we're going through it at the moment, we're creating our plastic extrusions, and what we're finding is obviously if we need to create just a quick sample part for a customer, we've got to spend all the money on the tooling. So how can you help us out? Well, very quickly and very easily. Instead of having to go through and spend the thousands of pounds on the tooling per individual quick test piece, even if it might be just 100 mil, whatever, small kind of sizings, well, we can actually go through and print that on the Form 3 for a far fraction of the cost. Might end up being kind of, let's say, around about £1 mark in material for 150 mil kind of size length piece, like that one's shown there. So it's a really fantastic opportunity, so we can go through and we can actually use the versatility of the printer itself and the injection mold style quality out of it to really gain a nice kind of monetary value to the overall. So again, we'll run through another one of the case studies, just like with the Ultimaker we had there, kind of one of their standardized one. Thought we'll discuss one for Formlabs as well, which is regarding the work they've done with Gillette. So what Gillette wanted to have was the versatility, the ability to run through and use several different types of resins to get a feel for the tactile feedback of using razor blades. So that's kind of allowed them to go through and just push through so many different designs. Again, it's that versatility that it can give, along with that customizability, and any of these changes they need to go through and do, they can print out. As I mentioned, it's the resins as well. They can play a huge part in it. We can see the different colors, and that's one of the easiest way to see if it's a different material on side of Formlabs printer. So we've got the blue, the white, the dark grays in there. So that could be indicating they're using one of the rigid resin, which has a really high stiffness due to having glass particulates inside the resin itself. The blue could be the tough resin, which is going to be almost like the ABS. And that dark grey, it could even be they're flexible, which is going to allow us to have that kind of cushion to the actual feel of the grip itself.
So when it comes to large format 3D printing, the solution that we offer is the BigRep 3D printer. So there's a few different 3D printers in the range, but the sort of sizes of parts that you would be expecting to get off a BigRep printer would be around the meter cube size, so printing really big parts. So if you're looking to make scale prototypes, one-to-one scale, sometimes if maybe you're designing a bit of furniture, maybe it's a chair. If you've ever had the issue where you look at something in CAD and then you 3D print it and it seems totally different to how it looked in CAD, being able to 3D print at one-to-one scale is sometimes a really valuable thing to be doing for some companies. So large-scale 3D printing offers the possibility of nesting more components as well. So the BigRep 3D printers use a patented extrusion method called MXT, which allows them to print a lot faster. So you can nest a lot of components and have them print, say, overnight. You can come in the next day and have 10 of those components ready to go. No waste material to worry about. So I'm going to jump into a case study here where the BigRep 3D printer has been used to make a pattern. So this pattern previously would have been made on a CNC machine. Some patterns have very complex geometry, which is going to require a lot of complex tool paths, maybe multiple operations, and it's really going to drive the cost up of a pattern. Whereas this one has been 3D printed on a BigRep. They're able to do it all in-house as well, having full control over the process. Whereas if you're getting your patterns outsourced, you might end up with a little bit of a communication breakdown with a supplier, possibly making parts take a lot longer to get finished off and lead times increasing drastically. So speeding up prototype production by over 90% with their BigRep here, and 5 times less expensive to make this pattern than the previous method. And they've been able to cut out outsourcing, basically, as I just spoke about, and bring production in-house, which is giving them full control there. We've also seen a lot of, impellers. Patterns for impellers are a real big one. So if you're doing anything like that currently, get in contact with us and we'll be able to talk to you about how you can make patterns on a BigRep 3D printer. So here's a case study from Boyce. So they were previously mass producing these parts on a CNC machine. Previously, the sort of tool paths required for something like that with that complex geometry was driving the time spent and the cost of the parts up. Whereas complex geometry on a 3D printer doesn't ever cost you anything extra. They're also not having to store huge amounts of material now. The material that the 3D printer uses is everything that goes into the part. There's no waste material to worry about. So requiring 60 to 80% less material storage currently, and eliminating waste material as well and the costs associated with that. And also the amount of personnel required to run the machines to take the prints off each day and put another job on is far reduced. And a lot of those CNC machine operators are able to spend their time elsewhere on other projects, higher value projects, whilst the 3D printers can be chugging away, making some of these other parts that don't necessarily need to be done on the CNC machine. So here's a quick case study of how the BigRep 3D printer is being used in the architectural industry. So that previous case study just really illustrates how much money can be saved from producing casts on a 3D printer rather than perhaps making them out of MDF and having them be far more bulky and not being able to deliver those molds to site. So if you're looking to understand, what sort of investment is going to be required with a 3D printer and whenabouts you're going to start to see a return on that 3D printing investment, and we have a process in place which starts off with data collection with yourselves, where we'll talk about the application, the current costs of the current method, and then we'll have a look at the 3D printed costs, and then we'll start to do an analysis, which will be a financial analysis. So that financial analysis will actually show how quickly a 3D printer will actually pay for itself making those parts. And then we can go through and do some functional testing with you, where we will 3D print the part in question on the machine that we think is most suitable, that we've discussed with yourself. And then we've really got a lot of our bases covered there, making sure that the printer makes financial sense and that the parts are going to work for you. So there's two ways of doing this. Previously, we'd do this through a walk the line, where we'd come and visit your site and would have a look at all the different 3D printing opportunities. Currently, because of coronavirus, we're doing a lot of this over the phone at the moment. So we've really tailored our process for working remotely, and we'll work with you to identify 3D printing opportunities remotely through pictures, CAD files, online meetings. So that's working very well for us at the moment. So do get in contact if you think that there are some areas in which you'd like to investigate whether 3D printing is going to work there. So what does the financial analysis look like? So this is a return on investment study that we did with a company that was looking to replace all of their store parts. So they're currently buying in a lot of their store parts, and there's long lead times associated with doing that too. And what they actually found is that they could be 3D printing their store parts far cheaper, and also not having to wait nearly as long to get those store parts delivered and in use. So with this case study in particular, what we found is that from looking at their store parts, there was like a range of needs there. Some of them needed to be quite flexible, some of them needed to be higher strength, and some of them maybe needed to be FDA approved. So as you can see to the left here, we've actually come up with a suite of 3D printers that works for them to produce all of their store parts and replace any outsourcing. So the average cost savings of 3D printing the parts is far lower than the outsourcing method, as you can see down the bottom here. And the lead times also drastically reduced. So they're not having any production downtime, which is really costing them a lot of money each time that happens. And the payback period is a far longer one on this one, 13 months. Typically, when we do these ROIs, it's usually around the 6-month mark or less for a payback on a Markforged 3D printer. But with the Formlabs and the Ultimaker and the whole suite and the sheer amount of parts that they're looking to do, this one's a little bit longer. So there's also finance options that come into play when we're doing an ROI. So sometimes to offset the initial investment, it can make sense to use a finance option. And then from day one of producing your parts on a 3D printer, you're already making a profit from day one, whereas as you're not having that initial capital expenditure. So as I mentioned previously, we'll work with you once we've done some financial analysis to functionally test your parts. We'll also advise you on how to design parts for additive as well. And what does the justification usually sound like? So some of the things that we usually talk about when we've done a financial analysis and proved that parts are going to work for you, usually we'll be able to say, you know, the 3D printer is going to pay for itself in about 6 months. We're also going to have to be able to look at previous issues where possibly prototyping wasn't taking place and previous costs associated with potential mistakes that might have been being made, where if you've been prototyping, those costs would not be happening again. And also analysing where money has been lost during production downtime. And also looking a little bit at lead times as well and how many more projects could have been taken on if you were able to complete the past projects faster and if you're able to reallocate some of that human resource on the other projects. So will 3D printed parts perform? A good one to talk about when talking about whether the parts are going to perform is using Markforged as a case study. So Markforged is a fully enclosed platform. So the 3D printing hardware, materials and software are all designed to run together with each other. So there's no unknown factors being brought into the equation. Maybe with some lower grade FDM machines, you might be buying, say, materials from Amazon or all sorts of different places. And that's where we start to see a lot of issues where some 3D printers maybe don't have the right kind of settings for running all sorts of different materials that people might be trying to run, and just different parts of the 3D printer kind of not really designed to work with each other, whereas on the Markforged platform, everything is designed to work together. So let's go into the materials. Markforged materials, so you can print with a base material, which is either a nylon or an onyx, shown on the bottom of the graph here. So the onyx material is nylon based with chopped carbon fiber particle within it, and that alone is stronger than ABS, almost twice as strong. So if you want to achieve higher strengths above that base material, what you're going to need to do is start to fiber reinforce those parts, as I discussed earlier. So when you lay some fiber reinforcement into a Markforged part, you'll start to achieve far higher mechanical properties. So with Kevlar reinforcement, you may want to put Kevlar in if you're looking for a more gradual stress strain curve. If when the part breaks, you want it to bend before it breaks, possibly, or maybe for vibration resistant applications, maybe for work holding on a CNC machine, stopping the amount of vibration going through to the part being cut. So you might want to use Kevlar reinforcement. High strength, high temperature is something that you might use in a mold, like that one which we showed off by Humanetics earlier. And carbon fiber reinforcement offers the best strength to weight ratio and will take the strength of a part above aluminium. So you can see this quick image to the right here showing how fiberglass reinforced onyx is able to hold up under weight, really increasing the rigidity over the base material. So you can really start to design the rigidity into the parts where you need it. So I also mentioned that the software is designed to work with Markforged as well. So I'm going to very quickly run through how the software works. So you'll start off with your library of parts here, which is all cloud-based. So you can be uploading parts from one location remotely, and somebody else can be viewing that, possibly where the 3D printers are, where your operator of the 3D printers is, but you can be slicing those parts remotely. So this is the process of laying down the carbon fiber reinforcement into a part. So he's going to go into this internal view here, and you can see those blue layers that are being populated there are where the fiber reinforcement is being put into the part. So usually you will try to create like an I-beam arrangement with the fiber reinforcement, having fiber at the top and the bottom of the part. Whereas if you're putting fiber in the center of the part, usually it's not doing a whole lot. As I mentioned earlier, all cloud-based, and you can view what your 3D printer is doing at any time and the progress of any job of any of the 3D printers on the network. So how do we ensure accuracy with Markforged 3D printing? Markforged 3D printers come with a laser inspection feature. So you're actually able to 2D scans of the part as it's printing. So if maybe you were printing, say, a sphere inside a sphere through conventional inspection methods, it would not be possible to measure that internal sphere, as it would not be visible. Whereas if you're scanning a part as it's printing, you can measure all sorts of intricate internal geometry and make sure that that's meeting tolerance. So you're going to see the scanner running over the part here. This is what it looks like when it's printing. So it's just going to do a quick print of the part there. And then the scan will begin. So you can put as many scan layers into a part as you would like. Usually you would put it where you want to be very sure that that area of geometry is meeting tolerance. So maybe around specific hole features that need to be within a certain tolerance is where you might want to be making sure that you have a scan layer. And once you've done a scan, you can then inspect that scan and make sure that the part is meeting tolerance. So you can see the scan layers being populated on the 3D model now. And once those are all populated, we can then go into an individual 2D scan and then interrogate that data. So to the right, we've got a graph here which is showing how far over or under tolerance areas on that 3D print are. And we can actually mouse over regions and see, whereabouts that area of geometry is. And we've got measure tools in there as well for creating the inspection reports. So that covers in-process laser inspection. So if you're currently using a 3D printer and you're finding that some of your parts aren't performing quite as well as you would hope, or you want to get more out of the 3D printer, or if you're looking to possibly move to other areas with 3D printing that you haven't tried to tackle yet, then do get in contact with us, as we have a whole range of solutions that cover all the different areas. So if you're looking to potentially move to stronger and more accurate parts, then we can advise you on that. Higher resolution parts as well, niche materials, and also 3D printing management software. If you've got a fleet of 3D printers and you're trying to work out a workflow for managing that fleet, and you maybe only have one additive engineer for 20 printers, it can get a little bit tricky using all the different slicing softwares. It can be good to have one place to manage everything, which we can help with. So what's the best 3D printer and material for you? The best way to get to the bottom of that is to get in contact with ourselves, as we've got a large technical team here that are geared up for doing just that. Everybody at Solid Print 3D has engineering experience and has come from an engineering background, so we really understand the sort of problems that you might be facing on a day-to-day basis. You can also have a quick look at the website as well, where we've got a help to choose section geared for doing just this as well. So I'd really recommend checking that area out if you're very new to additive and you're trying to hone in on what sort of solutions are going to be the ones which you want to be looking at for the application in mind. So something else that we get asked a lot as well is, what sort of training is required and what are the ongoing costs? So like with any other manufacturing method, there is a lot to be learned with 3D printing, much like if you were new to CNC machining. It is a new process, and design for additive is an important thing to be bearing in mind if you're moving to 3D printing. A lot of information through the news is very much giving the impression that you kind of throw something at a 3D printer and you print it and that's all there is to it. But a lot of the time it is possible to 3D print almost anything, but whether that's the best way of doing it and whether you're going to be reducing the risk of failures sufficiently by just throwing something at a 3D printer without going through the design for additive phases, or if you're going to be getting the best performance out of the part, you're going to want to make sure that you're designing parts for additive. So we have experts here and courses geared for doing just that. So can you trust the information that you're receiving? So Solid Print 3D was founded almost 2 years ago now, and we spent a really long amount of time investigating all the 3D printing options out there, and we've gone with the brand leaders in each area, and we've really spent a lot of time researching the different 3D printing brands, and we don't just offer one technology, and we don't just try and push that for every application. So we've geared the way that Solid Print is set up around being very application driven. So we always spend the time understanding the application before we start moving towards any sort of solution, and we go through that full process with you each time. So I'm going to move to Q&A now. So if there's any questions that you guys have, please ask them now, and we'll respond to you straight away. If we don't respond now, then we'll definitely get back to you via email.
Fantastic. Well, thank you very much for that, George. So had one question pop in quite earlier on, which is a very fair point when you're looking at kind of the breadth of 3D printers out there, which is when it comes down to new users hopping onto the printers and the software associated to them, what are kind of the most common problems or stepping stones and hurdles they have to find themselves going over? Again, it's going to be completely depending on the printer itself. So I'll run through a few of them and hopefully give a bit of a run through. So, for example, Markforged, it's getting up to grips with IGA, as George ran through there, understanding the processes where you're going through. How do you add in fiber, and why do you need to add in fiber into those different areas? That kind of I-beam method of adding the materials, the thicknesses of the fiber itself to the top and the bottom, little things like that. Printers themselves are going to run smoothly. So we can run through into other ones as well. So let's say, for example, Formlabs. So Formlabs, one of the biggest things you're going to find is it's a very, very different way of printing to your normal FDM. If you're coming from an FDM background, you've fused deposition modeling, or your hot glue gun and rails, you can obviously be printing and having the largest and the flattest surface on the build platform. In Formlabs, their printing, it's a little bit different. You're going to want to have some angle in the orientation. 45 degrees across 3 axes is the best way to achieve this. So when you're going through and doing your setup, that's usually one of the first hurdles you find people have to get over. As soon as they realize that, again, it's smooth sailing with the prints. Your Ultimakers, you're going across into your Syndos even. The majority of the thing is just the general day-to-day getting up to grips with how the machine works. So the whole process, how to load a filament in. You do it once, you get grips to it, and then it works fine from there. With regards to the software side of thing, then it's more the terminology from what I've seen. Little things, for example, using build plate adhesion tips and tricks. So adding your brims, your rafts, and your skirts. If you're not familiar with those terms, effectively it's just the addition of extra material to assist with getting your print to stick to the build plate and not creating spaghetti. So it's little top tips like that when we're going through. It's just more the understanding process of how to use the fantastic tools that are actually built into the slicing software itself. So hopefully that assists with that question. And if you do have any more, please do fire away inside the questions section. If not, please do contact us on our main number on our emails, and we can get back to you directly if you prefer that.
If you'd like to get in contact for a free sample part on any of the printers that we've gone through today, if you're interested to see what sort of results you can actually get off of one of these 3D printers, then we'll be happy to assist you with that. We have the whole suite of 3D printers in our head office here, producing samples all the time. So if there is a part that you would like to possibly get a custom sample done and then test that in-house, get in contact with us, and we'll be happy to help. Thanks for listening, everybody. And if you do have any more questions, don't hesitate to email or call. Thanks.
Cheers. Thank you very much.